Here we go. All right, so let's do this. I got a pen. Let's do the brush. Oh, I know why. Now let's do the brush. Okay, so what are we doing? We're doing section. We're skipping. We were on 8. We're going to go to section what? 10, 11, 12, 13. Lucky 13. So we're doing section 13.1. And it's about trig. Do you remember doing some trig stuff last year? Did I teach any of you guys in geometry? Taught some of you. About half of you. Okay. All right. So in trig, we use, let me turn this. Trig, we use right triangles, correct? So here's a right triangle. Isn't that cool? Let's make it just a little bit bigger. That looks good. Okay, let's label this triangle. This actually, first section, basically takes what you did in geometry that took like 3 or 4 different sections, and it combines it all into one section. Okay, so we're gonna do a little basic, what would you call it? Just review, foundational kind of work on the trig stuff, and then we'll get into some deeper stuff. We may not even finish. In the other class, we didn't quite finish. It's Wednesday. The class is a little shorter too. So, all right. Well, let's do this. If this is a right triangle, let me try to draw a little right angle there. Okay. And let's say we are referring to this angle right here. What's the general symbol that I used for an angle if I don't use regular letters in the alphabet? Do you remember that thing? Yeah, it's that. It's theta, right? Do you remember that? Okay, it's theta. I didn't have you in geometry, did I? Okay. So you remember doing that last year? It's just a basic, it's kind of a universal symbol for an unknown angle. It comes from the Greek alphabet. It's actually a letter in the Greek alphabet. You've probably seen it in like fraternity, sorority things, you know, the theta, this, and all that. Okay? All right, so that's what a theta looks like. A circle with a little swooshy thing through the middle of it. All right? And I use that a lot of times for a missing angle. And people do that in general, not just me. All right, so if we're referring to this angle right here, let's start with this side. This is most obvious. What is this side called? This is the hypotenuse, okay? So I'm just going to write HYP for hypotenuse. It's kind of hard to write on this while you're looking here and you're writing somewhere else, but I think the more I do this, the better I'll get. All right, so again, according to, now, it doesn't matter which angle you're talking about, this one at the top or the one down here on the bottom, that this is the hypotenuse. This will always be the hypotenuse. Why is it always the hypotenuse? It's opposite the right angle. Anytime it's opposite the right angle, that's the hypotenuse, okay? Now, if I'm referring to this angle theta right here, what would this side right here be called in reference to that angle theta? It'd be the opposite side, okay? Did you do this in your geometry class last year, the trig stuff? In pre-algebra, wow, okay. And what about this side right here? It's adjacent, okay? So ADJ, I'm just shorthanding it, obviously. All right, so we have some words. Basically, we have 3 words that describe the relationship between 2 of the sides, okay? And you remember what the words are, don't you? Yep, sine. And we always take the sine of the angle. It really depends. It really makes a difference which angle we're talking about, okay? So it's the sine of the angle, it's the cosine of the angle, and it's the tangent of the angle, all right? Now, you just have to remember what the relationships are. Now, remember, it's just a ratio. The sine, cosine, and tangent, Brandon, you watching? It's not a good way to start off. The sine, cosine, and tangents are words that describe the relationship between 2 sides, okay? It's just this over this, all right? I don't know where they got those words from or anything, but the sine represents 2 particular sides. One side divided by another side. Do you remember what that is? That's it. It's opposite over hypotenuse. Okay, and the cosine is the adjacent over hypotenuse. And the tangent is? Very good. Opposite over adjacent. My writing's pretty bad. All right, then we had a little mnemonic device. Do you know that word? Oops. It puts this little clicky thing. It's like a right click, you know, on the pen. And but they put it in a dumb spot because it's right where I grip the pen, and I always accidentally click it. And then, so I'll probably do that 100 times. All right, let's see. I'll do this. Sine equals opposite over hypotenuse. Cosine equals adjacent. My writing is getting worse and worse. It's supposed to be getting better. Tangent is what? Opposite over adjacent. I think I just have to slow down. And you said it already. Stephen, what was it? SOHCAHTOA. SOHCAHTOA. So if we write it out like this, it's SOHCAHTOA. Remember that, don't you?
Mm-hmm.
Okay. And it's just an easy little device to remember which one is opposite, hypotenuse, and all that. You never learned that one? You just memorized it straight up. Okay. This is kind of helpful, though, don't you think?
Yeah, I like
Do you
it.
use this? Yeah, I used it. In fact, when I learned it when I was in high school, I learned Toa Soka. That's the way my teacher taught it. And so for years, I always said Toa Soka, but then I started teaching, and I taught Toa Soka for years and years, and then I came here, and everybody's like, "Oh, I learned it SOHCAHTOA, SOHCAHTOA." So I'm like, okay. So I've changed to SOHCAHTOA, but I always learned it Toa Soka. All right. Anyway, how big deal? What's this stuff used for? Well, I'm glad you asked. Yeah. So let's put another right triangle here, and whoops, let's grab it right there. Make it a little bit bigger. All right. And let me go to the pencil. Somebody in the other class said this wasn't dark enough, but I think I write neater when it's the pencil instead of the brush stroke. All right, let's just do this. Let's, instead of calling it theta, let's call this ABC. Can you read that all right?
Yeah.
Is that all right? Okay. So it's ABC, and let's just make up some stuff here. Let's say that that's, I don't know, lucky 13, and let's call this X, and let's call this 12. Okay, I know it's not to scale, it's obviously not to scale, but let's just do that, all right? And we're going to find out what now at first, when they first ask you this stuff, they're just going to ask you for the sine of A. They're not actually going to ask you to solve for angle A. Now eventually they will, all right? But for right now, we're just going to find the sine of A and the cosine of A and the tangent of A. And we'll do the same thing with what else?
Are the angles capitals
Yeah.
besides the lowercase letters?
Yes. Usually, for the most part, it doesn't always have to be like this, but for the most part, the capital letter is used for the angle, and a lowercase letter would be used for the side. Okay. So sine of B. Let's see what cosine of B. Tangent of B. All right, so let's find these. Now, I'm not really finding the angle. I'm just trying to find the relationship between them. So this is just a little skill to get you to learn how to find the sine, cosine, and tangent of the angle. So the sine is what? If you look up here, it's so. So it's opposite over hypotenuse. Now, it's angle A, all right? So we're talking about this angle right here. So it's the opposite of angle A, which is what? 12 over the hypotenuse, which is 13. Okay, so easy enough, 12 over 13. So that's the sine of A. Haven't really found out what angle A is equal to. We can do that really quick in a second. But that's just the sine of A. The cosine of A, well, here's angle A. We need what? The adjacent over the hypotenuse.
That would be that.
But we don't know what this is, do we? So how do we find that?
We use Pythagorean.
Good, use Pythagorean theorem. Okay, so let's do this real quick. So it's x squared plus what?
44.
12 squared, well, we'll just write it out, equals that. So it's x squared equals, what's 13 squared? 169 minus 144 is 25. Okay, I can't write that fast. So x is what? 5. All right, so we'll just put it right here. Okay? That's actually one of our special triangles. Do you remember that? Remember a 3, 4, 5 triangle? Well, this is one of our special ones. That's why I picked 12 and 13, because it's 5, 12, 13.
Pythagorean triple.
It is, yeah, they call it Pythagorean triple. Okay? So, so then now we know the adjacent. So the adjacent is 5, so I've got what? 5 over 13. The tangent of A is opposite over adjacent. I pointed to that, so it's 12 over 5. Okay? Now watch. If I had this whole triangle covered up and all I saw was this right here, I could actually find the sine of angle B and the cosine of angle B and the tangent of angle B. I just want to show you the relationships because it's just kind of interesting to see that. All right? Before we do that, I'm going to stop this because I got to stop it at 10 minutes.